Hello guys, you are welcome to another section of learning with Prepclass. I am Tutor Chima. I'm your chemistry tutor. Look at your screen, you are going to be seeing Jamb Chemistry 2019, all questions solved. This tells you that I am going to be solving past questions on Jamb Chemistry for the year 2019. If you've not been seeing our previous videos, in our previous videos we've solved past questions on this same section from number 1 to 30. So today, I'll be taking you guys on questions 31 to 35. So students, first and foremost, I want you to subscribe on our YouTube channel, like our video. Feel free to drop a comment on our comment section box on any question that you are or you have for us, so that we'll always go through it and we'll know how we'll help you better. Click the notification bell so that you will be the first person to be notified of any educational content like this that we have on YouTube. So without wasting your time, I'm going to move straight to the business of today. Okay. Question number 31. Dissolving some pellets of NaOH in water would result in dissolving some pellets in NaOH in water will result in A. Is it a decrease in free energy of the solution? B. Is it a decrease in entropy of the solution? C. Is it a lowering of the temperature of the solution? D. Is there an increase in entropy of the solution? Now look at what I said. I said free energy, delta G, is the energy responsible for bringing about a reaction of a chemical change. For a spontaneous change to occur, delta G must be negative. A decrease, which is a decrease in free energy. If delta G is positive, the reaction will not take place unless some conditions such as what increase in temperature is met. But since NaOH will react instantly with water with the release of what? Heat, which is an exothermic reaction, delta G will decrease. So when you drop a pellet of NaOH in water, it's going to react instantly with water with what? Evolution of heat. If you put the pellet of NaOH in a glass, let's say in a test tube, then you add water. As the NaOH dissolves and reacts with water, if you touch the bottom of the test tube, it will become warm, telling you that heat is being given off in the surrounding, which is what? An exothermic reaction. So since NaOH will react spontaneously with water, that simply means that, I said that for a chemical change to be spontaneous, delta G must be negative. So since NaOH will react spontaneously with water, that simply means there will be a drop in what? Free energy. So that should be your best answer, a decrease in free energy of the solution. So our best answer is a decrease in free energy of the solution. Alright, question number 32. The alkanol obtained from the production of soap is it ethanol? Is it glycerol? Is it methanol? Is it propanol? Now, the process of making soap is known as saponification, and is the process whereby a caustic alkali is mixed or dissolved in a hot fat or oil to give soap. Caustic alkali simply means potassium hydroxide or sodium hydroxide, NaOH and KOH. So if you want to manufacture hard soap, you use NaOH, that's sodium hydroxide. If you want to manufacture soft solid soap, hard solid soap, sodium hydroxide, soft solid soap, KOH, potassium hydroxide. So when you mix this caustic alkali into hot oil, there will be a reaction, and after it cools, it will now solidify towards soap. The liquid you see there is glycerol. And another name for glycerol is propane 1,2,3 triol. Sorry, this will be 3. Propane 1,2,3 triol. So propane 1,2,3 triol is also known as glycerol. So the name of that alkanol produced is glycerol. It's not ethanol, it's not methanol, it's not propanol, but glycerol. Question number 33. Bleaching powder CaOCl2H2O deteriorates on exposure to air because bleaching powder deteriorates on exposure to air Because A, is it that it loses its water of crystallization? B, is it that atmospheric nitrogen displaces chlorine from it? C, is it that carbon dioxide of the atmosphere displaces chlorine from it? And D, is it that bleaching agent should be stored in solution? So I said that when bleaching powder is exposed to air, it reacts with atmospheric carbon dioxide to produce chlorine. So now this is the bleaching powder, CaOCl2 solid plus CO2. So it's going to absorb atmospheric carbon dioxide to give you what? Calcium triisocarbonate 4, CaCO3 plus chlorine. So the question is, bleaching powder deteriorates on exposure to air because it will what? Absorb carbon dioxide to give out what? Chlorine. So which one is our answer? C. Carbon dioxide of the atmosphere displaces chlorine from it. They should not have used, well, okay, let us see, because that's the best choice. They say lose water of crystallization, atmospheric nitrogen, no. Since carbon dioxide replaces, they should have used the word replaces and not displaces. Carbon dioxide displaces chlorine from it, and we can see from our reaction here that of course carbon dioxide will react with this to give out chlorine. So that's your best answer. Carbon dioxide of the atmosphere displaces chlorine from it. Question number 34. The carbon atoms in a tin are, is it sp3 hybridized? Is it sp hybridized? Is it sp2 hybridized? Is it not hybridized? They are asking us if the carbon atom is either sp3, sp2 hybridized or not hybridized at all. This is a serious one because you need to know what hybridization is before we now talk about sp3, sp and sp2 hybridization. Okay, let us move. Now I said here that hybridization is defined as the redistribution of the energy of orbitals of individual atoms to give new orbitals of equivalent energy known as hybrid state. Hybridization is usually started from the excited state of an atom, e.g. carbon undergoes excitation. So now, since hybridization is just like the redistribution of energy levels of an atom into give a new orbital of equivalent energy known as hybrid state. Before an atom of an element must undergo hybridization, it must be in an excited state. In an excited state, there is usually a jump of what electron from one energy level to another. That jump of electron can either be caused by heating, application of energy. The energy can be in form of heating an atom of that element, or it can be by firing an atom of that element with an electromagnetic wave, or maybe by light or so. So bombarding it with an energy or heating it will cause that electron jumps. So now, this is carbon, and this is the electronic configuration of carbon. You know, carbon is it has a mass number of 12 and an atomic number of 6. So this will be the arrangement of its electron when it's in the ordinary state. So since it ends in the atomic number of carbon is 6, so 1s2, 2s2, 2p2. So that's the electronic configuration. 1s2, 2s2, 2p2. Okay, so if you fire it with an energy, either by heating or so, when it undergoes energy, it enters the excited state. You can see that one electron will jump from here and stay here as seen below. So in the excited state now takes place here in the 2s. So one electron will jump from here to here. This one is the electrons here, maybe I think they are much closer to the nucleus. This one are not too close. So one electron can easily jump from here and stay here. So you can have 1s2, 2s1, and 2p3. So it's now in the excited state. When carbon is now in the excited state, it can now undergo what? This hybridization that I'm talking about. So now let us look at the 3 types of hybridization. We have sp hybridization, we have sp2 hybridization, and sp3 hybridization. Okay, let's look at the sp hybridization. In the sp hybridization, you can see from the excited states here. This is the excited state of carbon. You can see from here when it enters the excited state, this one is not affected. So forget about that one. Excited state is from here that jump and stayed here. So you are going to be using this 2s1 and this 2p. This 2p3. So that's what we have here. This is your 2p orbital and this is now your 2s orbital. So from the excited state, you can see the hybridization. This 2p now becomes this 2p3 now becomes 2p2, and this 2s now becomes what? sp, the hybrid. So you can see that from here, one electron will leave here and come and stay here. One electron will leave here and stay here to become sp. So I said that one electron from the 2s orbital, which is here, and one electron from the 2p orbital, which is this one, we hybridize to form sp hybrid orbital. This is the sp hybrid orbital. One electron from here and one electron from here, we hybridize to form what? sp hybrid orbital, leaving this what? 2p. So forming one sigma bond sp. So when one electron from here combines one electron from here, it will form the sp orbital. This sp orbital forms a what? A sigma bond. So forming one sigma bond, that's from the sp, and 2 pi bonds, that's from the 2p. So these two electrons, 1, 2, will form 2 pi bonds. So this one that hybridize with this one to form the sp will form one sigma bond. Then these remaining 2 electrons here will form 2 pi bonds, making it what? 3 bonds. So making it 3 bonds and seen in alkyne, e.g. 18. So 1 sigma bond, 2 pi bonds, making it what? 3 bonds, and this is seen in alkyne. Alkyne, a very good example of alkyne is what? Ethyne. So ethyne undergoes sp hybridization. sp2 hybridization, you can see from the excited state here that 2 electrons will combine with this one to form sp2, leaving 1, 2p here. So I said one electron from the 2s orbital, which is this, and 2 electrons from the 2p orbitals, which is 1, 2. We hybridize to form what? sp2 hybrid orbital. This is the sp2 hybrid orbital, forming one sigma bond. The whole sp2 hybrid orbital forms a sigma bond, forming one sigma bond. That's from the sp2, and since only one electron is here, 1 pi bond from the 2p, making 2 bonds as seen in 18. Do you see? One sigma bond and what? 1 pi bond. One sigma bond and what? 1 pi bond, forming what? 2 bonds as seen in 18. So we can see that ethyne undergoes sp hybridization, 18 undergoes sp2 hybridization. Now let us look at sp3 hybridization. So from this sp3 hybridization, you see that one electron from here will combine with the whole 3 electrons from here to form the sp3 what? Hybrid orbital. So I said one electron from the 2s orbital, which is this one, and 3 electrons, 1, 2, 3, from the 2p orbital will now hybridize to form sp3 hybrid orbital. Now hybridize to form this, forming one sigma bond, only one sigma bond. So there is nothing here remaining, so making it one sigma bond and no pi bond as seen in alkanes, example methane and ethene. So you can see that what? Ethyne from alkyne undergoes sp hybridization, ethene from alkene undergoes sp2 hybridization, and what? Ethane or methane from alkane undergoes sp3 hybridization. So our answer is sp2 hybridization. So the carbon atoms in ethene undergoes what? sp2 hybridization, as you can see here. sp2 hybridization. So ethene undergoes what? sp2 hybridization. Question number 35. The shapes of CO2, H2O, and CH4 respectively are the shapes CO2, or the shapes of CO2, H2O, and CH4 respectively are there bent, linear, and tetrahedral? Are there bent, tetrahedral, and linear? Are there linear, bent, and tetrahedral? Are there tetrahedral, linear, and bent? So let us look at the shapes of each of them. So carbon 4 is straight, you can see. 180 degree. It's a straight. The shape of this molecule is straight. Water molecule is bent, H2O. You see. This one has a bond angle of 180 degrees. This one has a bond angle of 104.5 degrees. So it's bent. And methane has a tetrahedral shape, forming a bond angle of 109.5 degrees. So carbon straight, water molecule bent, methane tetrahedral. Carbon straight, water molecule bent, methane tetrahedral. So the answer is straight, bent, and tetrahedral. Straight, bent, and tetrahedral. So straight, which is linear, bent, and tetrahedral. So you can see it, straight, bent, and tetrahedral, which is linear, bent, and tetrahedral. So that's linear, bent, and tetrahedral. Alright guys, we've come to the end of this section of learning with prep class, where we look at past questions on chemistry, Jamb to be precise, for the year 2019. Look below here, you are going to see a link. We urge you to copy and paste this link on your browser. When you do that, it's going to take you straight to our WhatsApp group. Joining our WhatsApp group will give you an advantage of having been notified on any words, or you'll be getting either being notified or updates on the latest video we have available on YouTube. So until we meet again, I remain Mr. Chima. Bye and do stay safe.